Hi, everyone. Nice to see you all here once again. It's Rita from XGeeks. I'm not sure if you're new to our live streams on YouTube, but it's good to see you again. If you're new, welcome to our YouTube channel. You see us around once a week, usually. Maybe we'll have more surprises in the midterm. But today we have quite a special session to introduce you, and a very special guest to introduce you as well. Just before that, if you're new to the channel, once again, I'll give you a bit of an overview about what XGeeks is. So XGeeks is an engineering company focused on providing capacity to product companies. We're not the typical project company due to several reasons, and we could be here talking about it all the way in our live stream, but it's due to the fact that we have a huge focus on community, also a strong engineering culture, and a huge product drive as well. We have a great balance between project and products, and we've been building products across the way, and we've been partnering with startups and corporate companies to make their products thrive. We're actually growing our team a lot, so if you want to check our website, feel free to also do that, or leave us some questions in our social media channels. We're happy to address those topics. But with no further ado, I would like to bring to our stage, our XGeeks stage, Rudy. Hello, Rudy. Nice to see you here, which is a product manager from Payara, our partners lately. Rudy will take the lead and introduce a talk about how class data sharing can speed up your Jakarta EE application startup. So no further ado, Rudy, take the lead, and thank you so much for joining us once again. I'll share your screen and go ahead.
Yeah, okay. Thank you, Rita, for the introduction. And yes, as you mentioned, I'm going to talk about the class data sharing feature, which is a nice thing so that you can speed up the application startup, which is, of course, a hot topic these days. So stay tuned, and then you find out more about how you can do it and how it works and how easy it is without adapting your application. And that's, of course, also a very important factor today. It's not only writing it, but it's writing it efficiently, and that you can change it quickly and adapt it quickly to your needs. So if the class, so if the JVM needs a class, then typically it's searched through one of the class loaders that we have. We have several most of the time. But after that, the bytecode is loaded, then a few additional steps need to be performed. That's all in that linking phase. You have the verification of the bytecode. It needs to prepare and check a few things before the bytecode can be used, before it is allowed to put into the JVM memory, because there can all be kinds of malicious changes going on. There also needs to be some resolving, because with the introduction of dynamic languages and the dynamic invoke, that means that, of course, that it's no longer a static thing as it was in the early days, 25 years ago. And then some variable initialization, that's probably known by a lot of developers, the variables that get their initial values. And after all that, then the class, the bytecode, can be used by the JVM. But that means all those steps, that it takes some time and that it slows down your startup of the application. And that's one of the aspects that people say that Java is not suited because it takes too long to start the JVM, etc. But that class data sharing option, what I'm going to show you, is already there for several years, and is one of the possibilities to improve that startup time. So yes, I'm Rudy de Busscher, working for Payara, and I'm their product manager, so I make sure that the product roadmap is implemented and that we have something to show you every month when we release a product. But I'm also developer advocate for Payara, not only talking about Payara products itself, but for instance, like this CDS feature, which is a JVM feature, a pure JVM feature. But it, of course, is very useful to know in combination, for instance, with Payara. So Let's have a quick look of what I'm talking about today. In this evening, it's about a few of the JVM internals related to that class. Nothing too technical because it's not the idea that we become experts in how all that class loader issues and the streams and all those steps works. Even I don't know it. I only know the basics, and that's enough to understand the class data sharing. And we also have a look, of course, because why do we want fast startup? Is it always important, or is it just because it is a hype that everyone wants to do that? But when are the use cases when it is most suited to have a look at that startup time? Of course, I'm going to give a few demos because that's always nice to see it in action, especially as you will see that this CDS feature can be easily used and that it can be used in all kind of situations. Also to start up a Jakarta EE application runtime like Payara Micro without any changes and that you can have that performance improvement. So if you have an application and you have there the statement, new my class, what is the JVM doing at that moment before it actually allocates that construct in the heap, that it reserves space for the properties which are defined in the class. So first of all, as I mentioned, you have that Byte class loading through the class loaders. That's also a thing that is known by most developers. But then there is the verification step, because the bytecode is created by the Java compiler. Well, most of the time, that's one of the aspects why there is a verification required, because you compile it with the Java compiler, but you also have those dynamic languages like Kotlin and Scala, which also compile directly to bytecode. So there needs to be a verification if that bytecode that the JVM sees for that class is valid and can be used. There is also the check if the bytecodes which are found are valid for the version that you are running. For instance, you know that, or probably know that Java has added the record construct to the entire system. For that record construct is of course there is a new bytecode created to indicate that it is a record, but that it's only of course valid on JDK 14 and newer versions. So all those verifications needs to be done to make sure that once the code is loaded, the bytecode is loaded, that it can actually be used by the JVM itself later on. But there are since it is just a binary file, like a class file, is in a jar file or not, it is still a binary file. Between the compilation and that it is used by the JVM, there is enough time that someone, a malicious attacker, and especially if you download the bytecode from somewhere, that code can be changed. So there is also a check on some patterns in that bytecode, if that is reasonable, well, if that is a possibility of a certain sequence of bytecodes, so that we are sure that the JVM then is running some trusted code. So beside that verification step, which takes quite some time, there are other things that need to be done, also related to the fact that the compilation is not done at the same time than the execution. That class file derivation, which I mentioned there, maybe some of you have already encountered that incompatible class change error, which is thrown during that derivation checks. Is also a check to see if the if your system between compilation and using it during runtime is still the same, because you can compile with a certain method available, get data, for instance, a method get data, which has only one parameter, a string parameter. But at runtime, you provide a different version of that library, a different version of the jar file, where you have that same get data method, but now with two parameters, a string and a integer, for instance. At that point, at compile time, there is only a reference made to that get data, which expects one parameter, and now it sees two parameters. So that means that there is what's called the incompatible class change error. There are other cases which are checked, like is it still an interface and not an abstract class, and vice versa, and all kinds of things which are checked during this phase. We have then the preparation, which is more or less the variable initialization. It's not, if you look it up in the JVM specification, it's not exactly the same, but you can see it as the initialization of the variables. And then you have that resolution phase, which is resolving those symbolic references for that dynamic invoke, because we have those languages, those dynamic languages and support for it. So you see there are a lot of steps done between the loading of the bytecode through the class loader, and that the interpreter can use that code to actually create that instance then on the heap. That takes some time, and let's see how we can improve, how we can make changes, how we can work around these steps, that it becomes faster, your application startup. And in general lines, there are three possibilities to improve that startup time. One is that you have a no verify option of the JVM, so you can specify it on the command line. If you say add Java -jar, for instance, for starting up your executable jar file, you can also specify there the no verify option, and then that verification phase is not performed. For the verification on correct bytecode, patterns within the bytecode, if they are valid or not, it is not done. But of course, that opens the door for malicious code, which is, I think, not an option these days. So you should never use that no verify option, especially not in production, to start up your application. Another popular solution these days is the native compilation to native code, which can be executed directly by your operating system, and that you do not need that JVM anymore. But for me, that's not an option, at least not today. It will change. It is a relatively new technology that will change a lot in the following years. But today, the native compilation is rather slow. Just a simple application with a hello world, the static void main application with hello world, that takes already a few minutes to compile. Another more important aspect is that your native compiled code has a lower performance at runtime, what's called a lower peak performance. So it is native compiled, but that means that the sequence of all the steps which are done are fixed. It's not like we have within Java, where you have the JIT compiler, the just-in-time compiler, that it identifies some areas where it can make optimizations, and then it can change the bytecode even, or it can change, or it can even convert that bytecode to native code. We don't have that with that native compilation, which means that you always execute the same thing, and it's not optimized for your use case, for your scenario. And several tests have already indicated that the native compilation, after a few minutes, it always depends, of course, on your load, but after a few minutes, that your native compiled application performs slower, has a lower performance than your Java bytecode. You also have issues with reflection, because everything is fixed at compile time, so reflection is an issue. Also, you cannot add jars at runtime because it does not know about it, because it's no longer a JVM system. I think that the last bullet point is solved in the last version, that you have support for debugging and Java agents, etc. But as you see, native compilation, it is a very nice feature, and it will definitely have some nice use cases in the future, but today it is not ready. And then the class data sharing, which is also available already a few years, is then an option, because you can improve your startup time of any application without changing your application itself. So you do not need to use specific frameworks or specific constructs within your application. You can just use any Java application, and you can use that class data sharing option so that the loading of the classes is faster. But maybe one step back, because it's always nice to know that you can start, that you can improve the startup, but there are many cases where you don't need that faster startup, because most of the time your application startups just fine. And I'm not talking here about that those serverless functions where that a faster startup is also beneficial, but suppose that you have an application where you can buy some events, some tickets for an event. And now in this phase of the pandemic, it is again a valid use case that events are again organized, and that you probably want to sell tickets for it. But if your system is optimized to handle a certain amount of requests from the user up until that blue line there, which you see in the graphic, then if you go over that blue line because you have announced a new event from maybe a popular music band or whatever, then you don't want that during the few seconds that you go over that blue line and there is no additional microservice started up before, that you lose some connections because your system is overloaded. So you need to start up as fast as possible a additional microservice. You can say then, yeah, well, why I don't start a second one even below that blue line, but then you can have that situation, for instance, with that bump just before that peak there, where it almost touches the blue line, but it does not go over. So in that case, you have started up your additional resources a bit too early, and then that's not a big deal, but again, that is some additional resources, and is these days with your cloud provider, it costs you more money then. So in some cases, and again, I stress the fact that it's not for everyone required that you need to react fast in some situations, but in some cases, it is good that you can react fast to avoid some connections that are lost because you have a high load of user requests. So the class data sharing, it's a confusing name because when I read it at first, I was not interested because that's, for me, it was like static variables, sharing data between classes. But actually, it is sharing the data around the bytecode, the classes, the bytecode of classes in an efficient way. So upfront, so we are not doing during startup, but upfront we do already that verification and that derive phase. So we verify if the bytecode is correct and that all the methods are found with the correct signatures, etc. And that information is then stored in what's called a memory mapped read-only file. So read-only means it cannot be changed. That has the disadvantage that it cannot be changed. So it is just like the native compilation. It is a closed world and you cannot alter it anymore. The good thing is, of course, it is read-only, so we can have the guarantee that it's not tampered with, and that you can and that you do not need that verification when you actually use that information in that memory mapped file. Which means then that the loading of the classes, if your application startup, is much faster because that verification is not needed, that derive is not needed, and that information in that memory mapped file is organized in such a way that it can be used immediately by the JVM. So that memory mapped read-only file is even stays on disk, but is even mapped directly into the memory that can be accessed by the JVM process. Due to the fact that it is directly mapped into memory, it can also have the effect that the memory requirements are lower of your environment. If you have, for instance, multiple applications running on the same machine, then of course you can share that memory mapped file so that it can be used by multiple processes. And a classic hello world file, the public static void main with system out println hello world, uses around 437 classes. Improving the startup of that kind of application with that CDS, of course, that's not going to give you some noticeable difference because it's only 400 classes. That's maybe a few milliseconds, so that's not worth it. But Payara Micro and other runtimes, for instance, also Spring Boot, for instance, they use around like 15,000 classes because you have a lot of more functionality in there and you use a lot of more functionality than that simple hello world. Speeding up those loading of those 15,000 classes can, of course, make a noticeable difference. And as you will see, it is a really substantial change, and it brings that CDS in the picture for a lot of use cases and for a lot of scenarios. Not sure if there is already a question before I switch to the demo.
Not yet, Rudy, but I'm pretty sure we'll have some in the future. And this is also a reminder, if you have any questions for Rudy, you can feel free to leave them in the comment sections, either on YouTube or Twitter. Feel free. Go ahead, Rudy.
Okay, so the demo then. Always a nice thing. Hopefully it works good. I'm going to use the I'm going to create two examples. One is with the OpenJDK version with Azul 11, and the other one is with OpenJ9, because both of them support that CDS functionality, but they have implemented it in a different way. But the end result is the same, and also the performance improvement is also comparable. So let's first start with the classic OpenJDK version. This is one of the latest JDK version, as I mentioned, the Azul one. And as a reference, I'm going to start up Payara Micro with a rather simple application, Java -jar it is, and that we can see how long it takes to start up under normal conditions when we don't do anything. So we started up with as an executable jar file where we specify a directory which contains our application. The server starts up, and at the end, for those who used Payara Micro already, at the end you get information how much that startup took, the time it took, and now due to the screen sharing, it is a bit lower than under normal conditions, but it is still relatively fast, and 9 seconds. If you have seen before 5 to 10 years ago an application server starting up that took much more time. So this is our reference value, so keep this in mind.
Rudy, sorry to interrupt you, but it seems like we can see your screen because it's all black at the moment. Should it be?
No.
Okay.
So,
and thank you, Andrew, for noticing it. It was actually someone from the crowd. Thank you for that.
Probably I need to share it again because I switched from...
Mm-hmm.
Is it now okay?
It is, yeah.
Okay.
Okay, perfect.
Yeah, that's because of switching from Keynote. I had that issues before switching from Keynote to something else, then you can have an issue. So what I did is, so what I did, I just started up Payara Micro with an application, so you heard it, and this is then the reference. it is 9.7 seconds. And the time that we need to keep in mind to see how we can improve that startup time. The first thing that we need to do is to create a new executable jar file. And the reason why is that if you start up like in the previous example with this the Payara micro jar itself, it expands itself and then a new class path is calculated based on the contents of what's included in that jar file, because we also have the possibility to create a Uber jar where you also have that application itself within the jar file. And as I mentioned, class path issues are very strict with that CDS. So the first thing that we are going to do is start a Payara micro, but this time we create what's called a output launcher. You see here the command output launcher, the property. Then we have in that micro root directory, we have another jar file, which is now very small. I can show it to you, and I put -L, so you see it's relatively small, and all the information is in that runtime directory. So there you have all the jar files which makes up the Payara micro, including the micro profile specifications, for example. So based on that, we can do the first step for CDS. And the first step for CDS is that we need to have a list, at least in JDK 11 with OpenJDK, it is still required that you have a list of all the classes that you want to put in that memory mapped read-only file. So that can be created automatically by the JVM itself by using that -x here, the dump loaded class list, and then you specify a file name. And this -warmup is something specific from Payara micro, and I'll tell you in a moment what it does. That warmup now, it starts up the application again with so Payara micro with your application. But once everything is up and running, also your application is loaded, at that time Payara micro is immediately stopped. So you see there is here, took a bit more time because the JVM is now recording some information, but after that it is automatically stopped because we have now here our classes list file. So that was the goal of this execution, and that warmup is created especially for CDS. So you see Java classes, you see also parts of the older class fields that we use. And if I scroll enough, you see here, for instance, you have here also parts of the Payara micro runtime available as classes list. Once we have that class list, we can instruct the JVM to create that memory mapped file with the xshare dump option. We specify again that classes list. We specify here the name of that memory mapped file, and we of course need to link the correct jar file, that launcher which contains the entire class path. It takes a bit some time, but I like to stop on time, so I'm not going to execute it entirely. At the end, it creates that file, and you see something like this. You see that the number of classes are 14,000 in this case, and that it has some different kind of spaces. So it created a file, 100% in total so the size of that is 160 megabytes. So that is very big, you can say, and it is. But that contains everything about the JVM. It contains everything about Payara micro, and it contains also your application. So you can see it as a runtime, everything what is needed to run your application. And the only thing that you need to specify then is that at startup is that it needs to use that payara.jsa file. So if you look here, that file is created. We can check again for the size. You see also that it is read only, so for everyone, so no one can change it, no one can touch it. I did a run earlier on the evening, so that I did not need to wait for the time that it is created, because it takes something like 30 seconds to create. But once that file is available, you can just say that it needs to use that that file. Not everything is in that file. There are a few exceptions, so that means that you still need to specify your launcher. In our case for Payara Micro, because I will give you a list at the end why some files are some classes are not in that memory map file. So you still need to specify that jar file. And I get an error here, process archive file. Okay, it seems that because I stopped it at the wrong moment, that the file is corrupted, that file here. So anyway, I can show it you with OpenJ9, and I can show you the results of all the testing in more controlled conditions that we did than just here a session around the CDS feature on a YouTube channel. So the same thing can be done with OpenJ9 and a bit easier, because OpenJ9 with added JDK 11 of OpenJ9 has already the possibility to skip that step where you need to provide the classes list. So it does it in a more dynamic way. That's also available in newer versions of the OpenJDK. I think it's introduced in JDK 15 or something. That step is not required with OpenJDK, but OpenJ9 already had it with the JDK 11. So let's switch to OpenJ9. I have here also OpenJ9 available. It's also from an OpenJDK version, but it's a different architecture. It is a bit different, but it's also certified, so you can also use it to run your applications. And the option there, as I mentioned, don't need the classes list. You can just start with slightly different option of the Xshare, which is called Xshare classes, where you have multiple properties. One of the properties is the name of the file, that memory mapped file. Actually, in this case, it will be a directory with the file in it, and even multiple files, so it's not one big file. And the location of that directory is, in this case, the current directory. I specify a larger initial size of that memory mapped file, because by default he only allocates something like 128 megabytes, which is too small for our case here. But then again, we use that same that launcher, so that we have a fixed class called the warm-up to stop it immediately after it is started, and then that deployment directory where we have the application available. So this is the same step as before, but now it immediately creates that memory mapped file, so that we don't need to do it in two steps as we need to do with OpenJDK. And again, the server stops immediately. And also here we can use it at that memory map file again with that by using the same property. It's not in my history, or it is some deeper in my history. That's the OpenJDK one, and this is the OpenJ9 one. So the same share classes here, where I specify, of course, the same location and the same name. But as you see, it is now just the jar file for Payara Micro for the same reasons, because not everything is in that memory mapped file. And again, we do not need to specify the application because that's also already available in this information of that memory mapped file. So remember, we had the initial startup of 9.7 seconds. Now we have an application startup of the same application. I'm not testing that endpoint. I did not test it, but it works. But it only takes 7.1 seconds. So that's more than 2 seconds faster just by manipulating a bit of command lines. You can have a, well, I would say, rather nice speed up without changing your application. So I'm just going to show it like this, then otherwise probably we have a black screen again. So using CDS for OpenJDK, you have those 3 parameters, that class, that loaded class list, which is a list of all the classes, which is needed for JDK 11, but not for more recent versions. The archive file name, and if we are creating a memory map file with dump or using it. For OpenJ9, you only have that one file there at the xshare classes. You have more properties there, like the directory, but you have other options. There are like 7 or 8 options that you all specify on this one command line option here. The result is, and these are the results of our control tests, that if you start up your application in plain without doing anything specific with OpenJDK, you have something like 8.2 seconds, but with CDS it goes down to 5.2 seconds. And for OpenJ9, you have a reduction from 7.9 to 5.1. The memory is also a bit lower, mainly here only because we do not need to perform that verification, etc., which also takes a bit of memory and a bit of classes. But of course, we do not see here the effect of sharing that memory mapped file between different processes. But as you can see, OpenJ9 is known to be a bit more memory efficient, and you see here that you have a lower memory. You use it when you use it as is, in the plain version, and even with CDS, there is also something like 8 or 9% of improvement. So if you compare these values here, 8.2 to 5.2 and 7.9 to 5.1, then you have something like 35% increase of your performance startup, which is very nice if you ask me. These manual steps, of course, you can automate them through a multi-stage Docker file. You can put the archive file within the image, make sure that your layers are correct and that they can be reused, and then that can be a very efficient process. You can also put even the shared archive file outside on a volume, but then you need extra steps in the build to put it outside, or you have to use the Podman, the alternative for Docker for creating Docker images, where you can specify with Podman build immediately some volumes, which is not possible with the standard Docker command line. Then a last word about why not every class is in that memory mapped file. One obvious thing, which probably you don't think about immediately, is because you have dynamic proxies. your application creates proxies at runtime, probably. Of course, they are not there. So that means, or they are, the basic class is there, but the proxy itself is not there, of course, on your class path. So that means that you still need to provide your entire class path at runtime so that still the dynamic proxies can be created, because they are not available, of course, in that memory mapped file. There is also a restriction that 1.6 and older, or it is only 1.5 and older, cannot be used. Class files formatted in that format cannot be used, and you will also have a warning when you create that memory mapped file that those classes are not placed in it because the class file is too old. If there are investigations, you can see what is happening and what it is trying to do, as CDS is trying to do by the option -x log, load plus class. Then you get a very large log file, but then you can go into very detailed examination what it is doing and why it might fail, for instance. Again, if you think about it, it is very logic, but people tend to forget it, that that memory mapped file is, of course, version dependent and based on the JDK version dependent, but also operating system dependent, because I said that it's structured that file so that it is optimized for the JVM on that operating system. So if you update from one JDK version to another, one JVM version to another, 11.0.11, for instance, then again, you need to create that archive file because, of course, the Java is a little bit different between all those versions. That is about it, what I wanted to tell you about. We still have a few minutes for questions if there are.
So really, it seems like we don't have questions at the point, so it means that your presentation and talk and demo were quite insightful and clear. So I would say, oh, actually we have one question, so that was a great timing. So thank you, team, for your question. The question is it possible to create an archive for another JVM?
No, you can only create an archive for the JVM that you are running at that moment. So it's not possible to point to some other Java home directory to say that it needs to create a archive file for that version. So it is always creating an archive file from what it is running, because actually he dumps the most, not entirely, but he makes a dump of what is in memory at that time, and he dumps it to a file. So no, that's not possible.
Okay, thank you, Rudy, and thank you also, team, for your question. Are there more questions from the audience? Let's give some seconds for them to be written down, if in case they appear. In the meantime, I think, Rudy, if you don't mind, I think it would be actually pretty cool also to mention the work that we've done together, not only these talks that you've been helping us with, but also we actually created a very interesting, at least in our opinion, ebook together with Payara about mastering microservices with microprofiles and Payara in the cloud. So we'll leave the access to the ebook in the chat, so go ahead and check it out. We hope you enjoy it, and feel free to share your feedback with us.
Okay, so thank you for if there are no questions, so
it seems that we don't have more questions.
But thank you for the invitation, and I hope everyone enjoys the rest of their evening, or when they view it later on, enjoy the rest of their day.
Thank you so much, Rudy, for your help and for your talk and insight. It was great. I'm pretty sure everyone enjoyed it. Thank you once again for joining us, and see you next time. Thank you. Thank you, everyone, also for joining the talk. Bye. See you next week.
Bye.
Bye, everyone.